Hello everyone, I'm Honest Mertic. This is my video for E120 Lab 4. So let's get right into it. I'm just going to walk you guys through on how I put together the microprocessor with the adder generator, the controller, and of course the microprocessor. So first, this is the circuit to the adder gen. This circuit gives the processor memory and addresses either automatically or manually. There are two main parts in this circuit. The first part is the program counter, or short for PC, or PC short for program counter. It uses a 4-bit incrementer that updates the memory address automatically after each instruction. So every time the processor runs an instruction, PC just bumps up the address by 1. And then over here we have our MAR is the name, which stands for Memory Address Register. Just this one down here, the MAR. This is where we mainly load the address from the data bus that if we want to jump to a specific memory location. So we can choose between PC and MAR using ARM 4-bit MUX, which is controlled by signal use PC, or if use PC is high, then we use PC. If it's low, then we use MAR. So overall, this whole setup lets us either run things in sequence or jump around. So yeah, which is just key to if we want to do any complex programs. So that's with that one. Now moving on to our controller. This is basically the brain of our operation. It tells the rest of the processor what to do at each step. The core of this controller is our ROM, which is this over here, our microcode ROM. Just a fancy way of saying that if we store all the control signals in ROM, and each step gets broken down into smaller steps called micro ops. There are three key parts in this controller. The instruction register, IR, which is this one right here. It holds the current instruction we're executing. The next one is the step register, which is right below it, right here. And this just keeps track of which micro op we're on for that instruction, since one instruction can take multiple tests. And of course, the one we're just talking about, the last one, which is our ROM, it holds all the control logic and basically a giant lookup table. If you give it opcode and steps, you can basically just spit out all the control signals and the next step to go to. So every clock cycle, it just pulls a new set of control signals and steps to instructions like load or add and store, etc. And one cool thing is that every instruction just starts with a fetch, which is step 0, where it loads the instruction to the instruction register and then goes into execution steps from there. I thought that was pretty cool. Just showing it works. But yeah, I just thought it was pretty cool. But yeah. Also, let me just show that which one was it? Show that this works as well. Yeah, I just thought it was cool. The reset. Alright, now lastly, the main part, or not last on the circuits before I show the waveforms. Our full microprocessor. Yeah, now it just has everything connected, and we've got the full microprocessor. So the controller just runs the show, which is down here, telling components when to read or write and how data flows through the ALU and the registers. Then we have the brainless CPU over here, which handles all the basic data movement and arithmetic stuff that we set up in Lab 3, like reading values, doing math, loading to the accumulator, and so on. And up here, the adder gen is the address generator, which lets us either run things sequentially or jump to wherever we need in RAM. So when you put all these modules together, controller, adder gen, and brainless, you get a processor that can run real programs, which is cool to learn in a level 100 class. So yeah, I basically just tested things like load through an accumulator, turn the clock on, the clock cycle, clock, 3, 8, once it goes through all the steps, we'll go back down 3, 1, back to 0, back up to 7, and then 3 is where it ends off. And if I want, I can just reset it. So yeah, custom microprocessor. Yeah, so the address generator just gives us like a flexible memory access. Controller runs the ROM based stuff to handle instructions and timing. And we put all that together to get our microprocessor here. Of course, with the brand list that was from Lab4. So let me close that. Open up my template to show the values for my. Okay, so this is my ROM, my final ROM value here. And then here. Or here. So first we're going to start with our AND. These are my AND values. 0 loads into the actuator. 3 is the value to load. And 3. And value add 5. And then 2 stop. That will be, drag this over. So yeah, as we can see here, in this clock cycle, the accumulator is 0, 0, and it changes to 3, and it goes and adds 1, just basically showing it works with all of our data, and then it stops. So that's that one. Just to save time, I can't really explain all this. Also, I gotta be quiet. So yeah, has an AND, all that set up. Close that one. And next we have our 0, which is 0 is the number to load actuator, 3 value load up, 4 is 0 actuator, and 2 to stop. I believe it's this one. Yeah, to save time, all the values match compared to the numbers I had. Just a quick second of pause so you can look at it. All the values match. Get rid of that one. Next is our sub, which is this one. Just like the same as the last ones, the values match. 0 to load, 7 is the value to load, 5 is a sub actuator, and 4 is the value to subtract, and 2 is to stop. But yeah, there's that one to save time. And here we have store, which make this full size. Not full size, but so you can see the whole thing. Just like the last 3, it just stores the value. Everything matches, and yeah, and it's all good. And the waveforms, yeah, and that's my values for my ROM values. I can open up those files here. The micro stem, basically I just changed these values so it matches. That's that. How to change this? That's my RAM, or yeah, my ROM files. So yeah. Thank you guys so much for watching. That was my Lab4 report for Triple E120. Yeah, you guys have a good one.